So some plastic deformation, it can occur prior to failure if we want to check the fracture toughness. Toughness means for mainly for this kind of to check the ductility behavior. Load versus displacement. Displacement is nothing but crack opening. Here in this case, CTOD, load versus crack opening only they would be talking about. So let us see about this test details. Unlike the inexpensive 10 mm by 10 mm squared sharp PV test specimens with the blunt machined notch, the CTOD specimen may be the full thickness of the material, will contain a genuine crack and will be loaded at a rate more representative of service conditions. Conversely, 3 tests are carried out at the relevant temperature to ensure consistency of results. Whatever this sentence says about, here they will make some notch in the specimen and they will apply the load. Load will be loaded more representative of service condition. That means like it will be slowly the load will be getting applied. You can see here there are bent roller and then the bottom former. When they push this load up, it will start bend and then this opening, it will be expanding it. This is the clip gauge. Basically, it's a strain gauge. So we can measure the distance opening displacement. Let us see that one. The test piece itself is proportional. That means length, depth, thickness of each specimen are interrelated so that irrespective of material thickness, each specimen has the same proportions. That means they will be doing 3 tests, right? All those 3 tests will be having the same proportions. There are 2 basic forms, a square or rectangular cross section of specimen. Here you can see this is the rectangular cross section because B and thickness is B and depth is times B. Sometimes we can keep B by B. That's why they're saying it's either square or rectangular. If the specimen thickness is defined as B, the width will be either B or 2B with a standard length of 4.6 times this B. A notch is missing at the center and then notch is missing at the center. That means here you can see this is the notch. Here it's a notch, you can see that's missing at the center. And external by generating a fatigue crack. This is the fatigue crack, so that the total defect length is half the depth of the test piece. So here we can see this A is approximately equal to the half the depth. So the defect length will be almost half the depth of the test piece. This is the test piece 2B, that's the depth. So approximately B times they would keep this notch location with the fatigue crack depth defect length. So a test on 100 mm thick weld, you can see 100 mm thick weld, therefore require a specimen measuring 100 mm thick, that's a B value, and 200 mm is the total depth, and 920 mm long because of 4.6 times, right? So an expensive operation, a value of which can be only determined once the test has been completed. Let's see here. The test is performed by placing the specimen into a 3-point bending. You can see 3-point bending 1, 2, 3. So the test specimen is placed at the 3-point bending. And measuring the amount of crack opening. You can measure the amount of crack, how it's opening once the load is applied. This is done by means of strain gauge attached to the clip. So this is the strain gauge. It's a strain gauge attached to the clip. We can say this is the clip gauge. And these are the 2 knife edges. It is placed between the 2 accurately positioned knife edges at the mouth of machine notch. This is the mouth of this machine notch. This is the machine notch, right? So at this machine notch, we can place this accurately with the knife edge. You can see accurately positioned knife edge. This is a clip gauge. Whenever this mouth gets opened, you can measure the displacement. Okay. As the bending proceeds, the crank tip plastically deforms until critical point is reached when the crank has opened sufficiently to initiate clip gauge. Here you can see at some point of time it will be plastically deformed until the critical point is reached when a crank has opened sufficiently to initiate a cleavage crack. This may lead to either partial or complete failure of the specimen. So when we keep applying the load, it will create some partial or complete failure. The test may be performed at some minimum temperature, minimum descent temperature, or more early at the range of temperatures. The values that are required for the calculation of toughness are firstly loaded at which fracture occurs, secondly the amount by which crack has opened. So it means that calculation toughness are firstly the load at which fracture occurs and then amount by which the crack has opened at a point of crack propagation. We will see here. So since the length of the crack and the opening at the mouth of the notch are known, it is simple matter to calculate the crack tip opening by simple geometry. So here it's very clear, like if you see it's a brittle fracture, sudden latent fractures. This illustrates the various different shapes of curve that may be placed. Here A it versus a test where the test piece has fractured in a brittle manner. That means like without any plastic deformation. And the second one is excess of pop-in, where a brittle crack initiates but only propagates a short distance before it is arrested in tougher material. And this may occur several times, giving a curve a short appearance. The third one you can see here, which shows a complete ductile plastic behavior. That's a ductile failure. Location of the notch in weld or heat affected zone or parent metal is important. Location of the notch, because as an incorrectly positioned fitting crack will not sample the required area, making test invalid. So to be certain the crack tip is in correct region, to be certain that the crack tip is in the correct region, polishing and edging followed by metallurgical examination are often carried out prior to the machining of the notch fitting cracking. This enables the notch to be positioned very accurately. These things are okay, it's not a big thing. So this is the some basics behind this CTOD test. It's mainly measures this displacement crack opening versus load. But why do we do that? Is that just to say that the material is ductily behaving or not? That's the main purpose we are doing this. So here data specifications BS7448 fracture mechanics toughness test. BS77910 is a guide on methods for assessing the acceptability of flaws in metallic structures. ASTM E1820 BSEN